Hello, everyone. Welcome to our webinar tonight. We're just going to give it a couple more minutes to make sure that everybody is signed in. Thanks so much for being here. Just a reminder to turn everybody's cell phones off, and you will be able to use the chat function to send us your questions, which we'll take at the end of the presentation tonight. So hang tight, and we will be starting shortly. Okay, well, we've got a wonderful presentation tonight, so I'm going to get us started here. We are Saving Ocean Wildlife. We're a proud project of the Ocean Foundation. Next slide, please. And our vision is a healthy marine ecosystem where all wildlife thrive as a result of an informed society. And our mission is creating ocean partnerships to protect wildlife. Next slide, please. So who do we work with? Well, we work with a lot of different communities. First of all, folks like you from the general public. We also really focus on boaters and marinas because these are probably the folks that are going to be seeing wildlife most frequently. And so we really want to make sure we're outreaching to them and making sure that they have the right information so they can report on wildlife. We also have government partners. We're working very closely with NOAA, who's in charge of all of the strandings and entanglements for the state of California, as well as the state, because we work with the Division of Boating and Waterways to help get connected to boating communities. We also have scientific partners, as you'll meet Michael tonight, one of our scientists, and we also have partners in Mexico as well as Canada studying these animals that are migrating up and down our coasts. And finally, we're interested in partnering with businesses. So businesses that care about the ocean, about a healthy ocean, and the wildlife that live there are our partners as well. Next slide, please. So what's the work that we actually do at Saving Ocean Wildlife? We like to categorize it in 3 areas. The first step is really awareness. So we're trying to help everyone who might come out to the coast and see these animals to know what they are. So we have a free wildlife guide. If you haven't downloaded it from our website yet, please do. It's right on the homepage, and it gives you pictures and descriptions of the animals that you would most likely see, either from the shore or if you're out on the water. So that's really the first step, just get yourself familiar with those animals. But then we're also spreading awareness through our Dock Walker program and talking to boaters directly about the phone numbers they can call to report on animals. And also giving presentations like this, our webinars, we have our blogs. We also give private presentations that we give to different groups like yacht clubs. So we're really trying to get the word out on what are the threats to these animals and what can people do to make a difference. The second thing that we do, which I just touched on, is the reporting. So how confusing is it when an animal might be in distress? Do you know who to call? Do you call the police? Do you call the Coast Guard? We're trying to make it easy for folks to know what to do in that case where you might see a dolphin that's stranded itself on a beach, or you might see an entangled whale. It's usually a high stress situation, and just knowing who to call and who can coordinate a response is important. So that information is on our website as well. We have a very large reported animal button right on our homepage. We've got the phone numbers that you can call. And also in our direct outreach, we're trying to let people know what that number is. And then finally, action. You may be thinking, okay, well, I don't even get out on the water. I might never see an animal. How can I really help? On our website, we have our top 10 list. There's so much you can do. Just pick one thing, whether it's reducing your use of plastic or choosing better sustainable options for your seafood or volunteering. There's always something everybody could do. So please check that out on our website. Next slide, please. And here's what, if you remember nothing else, we want you to know, see it, say it. If you see an animal in distress, please, as quickly as you can, please report on this animal. Right now, there's a juvenile gray whale that's been traveling up from Dana Point, actually, on Monday, traveled up past Santa Barbara and is on his way to Monterey, or she, on its way to Monterey Bay. And it's only because folks have been reporting that this animal was spotted entangled that we're actually able to get the rescue teams out there. And they've been able to go out and attempt a rescue, but it's been very difficult. The mother's really blocking any type of rescue effort. They're scared. She doesn't want anybody probably getting near her calf, but the rescue teams are working hard to try to disentangle this animal. But again, if we don't have eyes on the ocean, if we're not getting folks out there looking for these things and reporting them, there's no chance at a rescue. So thank you to all of you that participate in this. Next slide, please. So that's enough about our organization. I want to now introduce our presentation for the evening, State of the Oceans Past, Present, and Future. And as I mentioned, Michael Atkins is going to be giving this presentation. So I'd just like to read his bio as an introduction to the presentation. Michael has been actively engaged in conservation efforts with marine life for 35 years. In fact, 30 years ago this week, in April 1991, he wrapped up a year-long study abroad of the effects of intense urbanization on coral reefs in the Red Sea. These were the most beautiful, pristine coral reef systems in the world, which drew thousands of tourists from all around the globe every year. But the rush to build mega hotels on expanded beaches right on top of these coral reefs was, to accommodate all of these tourists, was destroying the very thing that they came to see. This study was Michael's marine biology thesis at UCSC. Next slide, please. And for his PhD work, Michael studied the ecology and evolution of microbes of deep sea hydrothermal vents, where most scientists think life originated on Earth. In the course of this work, Michael found a living descendant of the microbe at the branch point from single to multicellularity. He continued studying the origin of multicellular life and the evolution of cellular complexity as a NASA astrobiologist, using the extreme conditions of deep sea hydrothermal vents to understand how the search for life beyond Earth, techniques likely to be used on Mars today. And with that, I would like to turn it over to Michael to give us his presentation on the state of the oceans. Michael?
All right, well, thanks a lot, Laura, and good evening to all of you. Thank you for joining us tonight. I'm coming to you live from Los Angeles, but unfortunately, once I start sharing my screen, you can't see me live on video. I'm using the iPad Zoom app, and for some reason, it shuts off the Zoom video feed when I start sharing my screen. So, but I will appear at the end when I stop screen sharing. I'm really here, so don't think I'm just some mystery guy in the background. As Laura mentioned, please feel free to ask questions throughout this presentation using the chat tool, and I'll be happy to answer as many of them as I can during the Q&A session at the end. And let us know your name and where you're from so I know who's asking a question and can let everybody else know. Now, I think it's appropriate to start an Earth Day presentation with one of my favorite images of Earth from NASA's Lunar Reconnaissance Orbiter, 83 miles above the moon, which you can actually see at the bottom. And what I like about this image is how clearly it shows why Earth is called the blue planet, because of our stunning blue oceans, the water of life. So let's take a deep breath and consider for a moment how this place we all call home is really a life support system for a tremendous biodiversity of interconnected plants, animals, and every other living thing. I want to start this off with a question for all of you about mass extinctions. And you can answer using the chat tool as practice for asking me questions later and throughout the presentation. So how many times in Earth's history has a single species, one species, changed the oceans, atmosphere, and land so completely that it threatened every other species with extinction? And this is not a trick question. Once, twice, more than 5 times, never. So I'll wait a few seconds for everybody to respond in the chat room. It's good practice. Okay, a couple more seconds and I'll tell you the answer. Okay, so it looks like some of you got it right. The answer is B, twice. And I did this kind of humorous little slide to talk about who they are. Cyanobacteria, during a nearly 3 billion year time frame called the Great Oxidation Event, and us over the last 150 years since the Industrial Revolution through destructive human activities. So in the entire 4.5 billion year history of Earth, only 2 species have so completely altered the oceans, atmosphere, and land that every other species was threatened with extinction at the time. Cyanobacteria were the first photosynthesizers on an anoxic Earth, pumping oxygen into the oceans and atmosphere for nearly 3 billion years. killing nearly every other living thing because oxygen was toxic to all life on Earth at that time. We've been doing it through water, air, and land pollution in a much more compressed time frame, only about 150 years, by burning fossil fuels while simultaneously eliminating natural carbon sinks through intense urbanization and bad land use policies, pumping massive amounts of CO2 and other greenhouse gases into the atmosphere and oceans, causing ocean acidification and ocean warming. We've done it through oil spills and other toxic waste dumped directly into the oceans. Plastics and trash carried into the oceans through wind and sewer runoff. Fishing gear lost or abandoned at sea, and other marine debris that entangles and kills all kinds of ocean wildlife. And mortality events with unknown or uncertain causes that may eventually be linked in some way to ecosystem changes caused by human activities. Now, these are all just snapshots in time, but the reality is we're doing this every second of every day. And cumulatively, it has had a profound impact on our planet over 150 years. So in this special Earth Day presentation, I want to talk about why the oceans are so important to life on Earth, including human life and our health. By looking at past states of the oceans, we can better understand the context and dynamics of changes occurring in the present and make more accurate predictions and models about potential future states of the oceans as well and what they mean for life on Earth. Now, the present epoch in Earth's history is called the Holocene. Nobody needs to know that, but that's what it's called. But some are proposing to rename it the Anthropocene. Anthropo means man or human, and scene means new. So the Anthropocene epoch is this unofficial unit of geologic time that's used to describe the most recent period in Earth's history when human activities started to have a significant negative impact on the planet's climate and ecosystems. And we're going to look at 5 key environmental issues caused by us that are threatening the oceans and ocean wildlife in the Anthropocene and what they mean for the future. And finally, and arguably most important, I will talk about ways in which individuals can actually make a significant difference by taking action in our personal lives to reverse the damage we are collectively doing. Now, one of the reasons the oceans are so important to life on Earth is kind of a biggie. Life on Earth began in the primordial soup of the early ocean, likely at or near hydrothermal vents at the bottom of the ocean, which is what I did my PhD on. And with just the right conditions, this gave rise to protocells and eventually the first single-celled life that adapted and mutated and evolved over billions of years into the wondrous biodiversity throughout Earth's history. To this day, 98% of all the biomass in the oceans is still microbial, like microscopic plankton and algae and bacteria and more. Microbes make up the base of all oceanic food webs, converting sunlight or chemical energy into food and energy for everything else. So since 98% of all biomass in the oceans is microbial, that means all the marine mammals, fish, turtles, and every other adorable creature we typically know and love throughout the world's oceans only make up the remaining 2%. Pretty incredible, huh? Well, that's why I think microbes rule, but that's going to be a different presentation. Now, the oceans are critical to maintaining the right conditions on Earth for life to survive and thrive. They are the largest feature on Earth's surface, as we saw in the first image of our blue planet. The oceans cover 71% of Earth's surface, and that's just the surface. They are also immensely deep. 4 kilometers or nearly 2.5 miles deep on average, and more than 11 kilometers or 6.8 miles at the deepest point in Marianas Trench called Challenger Deep. 95% of all the livable space on Earth is below the surface of the oceans, 95%. The oceans hold 97% of all the water on Earth. They are the source of 86% of all evaporation and receive 76% of all the precipitation on the planet. So as the largest feature on Earth's surface, moving and cycling all this water, the oceans exert considerable influence over long-term climate and short-term weather patterns all over the globe by storing and circulating and releasing solar radiation and regulating the concentration of greenhouse gases in the atmosphere, like carbon dioxide or CO2, by storing it as a dissolved gas in seawater and as a solid in the shells and skeletons of micro and macroscopic organisms that eventually die and sink to the bottom of the ocean, carrying with them all that stored carbon, where it will remain for thousands to millions of years. In this way, the oceans play the most important role on Earth in the biogeochemical cycling of water, carbon, and other essential elements and molecules around the world and through the biosphere. And last but not least, in this incomplete short list of amazing ocean facts, photosynthetic organisms in the oceans produce somewhere between 50 to 80% of Earth's oxygen. Again, because of the sheer size of the oceans relative to land. More surface area and depth equates to more production of oxygen than anywhere else on the planet. But unfortunately, climate change and other issues caused by human activities are affecting these biogeochemical cycles and the overall health of the oceans themselves, which in turn is affecting the ocean's ability to support life. And the only way that we can truly comprehend the magnitude and severity of these planetary scale changes we are causing today is to provide some context from the past. Now, in this intro slide, notice that I make oceans both singular and plural with the S in parentheses. Well, that's because throughout Earth's history, plate tectonics moved and shaped land masses, which in turn united or divided the oceans in different ways. When all the land masses were pushed together, there was one vast ocean called Panthalassa, surrounding one giant continent called Pangaea. Today, we have 7 continents separating 4 oceans: Pacific, Atlantic, Indian, and Arctic, and a bunch of smaller seas, each with their own unique properties and features. We've already talked about cyanobacteria and the Great Oxidation Event, or GOE, which started 3.5 billion years ago and lasted about 3 billion years, but continues with photosynthesizers all over the world today. All life on Earth was anaerobic and oxygen was toxic to them, so nearly all life went extinct. But oxygen was essential to the evolution of multicellularity and more complex life forms. So extinction events like the GOE are both bad and good for biodiversity. They're bad for everything that goes extinct, but they're good for extinction survivors and their descendants like us. We wouldn't be here without all these extinction events. Extinctions have happened throughout Earth's history, but some extinctions like the GOE are called mass extinctions because more than 70% of all species on Earth go extinct, most of which are marine species. In one mass extinction event at the end of the Permian period, 95% of all marine species and 70% of all land species went extinct. So these are huge. These are called the Big 5 mass extinctions. And we're going to zoom in on 3 of them to look at similarities between states of the oceans during these mass extinctions and the states of the oceans today. The 3 mass extinctions relevant for today are the Triassic, the Permian, and the Devonian. The states of the oceans during all 3 of these mass extinctions were similar, and similar to what we see today. They all had high levels of dissolved carbon dioxide, or CO2, which was taken up from the atmosphere, and that makes the oceans acidic. High CO2 in the atmosphere causes climate change, as it did then, and that resulted in warming ocean temperatures. There was a large release of methane in the Permian, which may account for why that extinction event was the largest of the Big 5. Methane is 20 times worse than CO2 as a greenhouse gas. So it's likely, that it accelerated and exacerbated climate change in the Permian. That event was short, but really intense, suggesting that living organisms didn't have time to adapt to changing conditions, killing 95% of all marine life. Climate change caused polar ice and glaciers to melt. Does that sound familiar? Both of which caused sea levels to rise. Warming ocean temperatures changed ocean circulation patterns, which changed the amount of oxygen in the ocean, especially the deep ocean. The state of the oceans today is very much the same as it was during these 3 mass extinction events, with 2 very important differences. The high levels of carbon dioxide came from volcanic activity then. Today, it's coming from us burning fossil fuels and removing these important natural carbon sinks through increased urbanization and bad land use practices. And we're causing these massive planetary changes in a much faster time frame. Past extinction events took hundreds of thousands to millions of years. We've done it in less than 200 years. There's much that we can learn about the present and potential future states of the oceans from the past. First of all, the oceans, atmosphere, and land are deeply interconnected. We can't realistically separate what's happening between them. What affects one affects all, including mass extinctions. The states of the oceans are constantly changing. In addition to plate tectonics shifting land masses, thereby uniting or dividing oceans, the oceans have warmer and cooler periods, rising and falling sea levels, higher and lower concentrations of dissolved CO2, all of which cause changing impacts on life in the oceans and everywhere else on Earth. The past states of the oceans also show us that extinction events, big and small, have always happened, and that the largest mass extinctions had causes in common, especially high CO2 and methane levels and subsequent climate change, ocean acidification, changes in ocean circulation patterns, and more. Extinctions are both bad and good for biodiversity. Extinctions are obviously not good for species that die off, but extinctions are good for renewing biodiversity by opening up ecological niches and creating new opportunities for extinction survivors and their descendants like us. It just takes millions of years for survivors to kind of renew the biodiversity on the planet. And only one major extinction event in the past was caused by a single species, cyanobacteria, during that great oxidation event, which came close to killing all other life on Earth over 3 billion years ago. We are the single species responsible for an accelerated mass extinction event going on today. Now, since the last mass extinction event, the biodiversity of ocean life has evolved into a number of species that we know and love today. So let's take a brief look at the amazing marine biodiversity in just a very small sampling of images from around the world's oceans. This is a montage of phyto and zooplankton that make up the base of oceanic food webs. This is what supplies the food and energy to everything else up the food web or food chain, whichever way you want to look at it. Most of those are photosynthesizers, so they are creating all of this energy and food from sunlight energy. These are coral reef fishes in the Red Sea in Egypt, one of my favorite dive spots in the world. Here we have scalloped hammerhead sharks off the Galapagos Islands. Mother sea otter with rare twin baby pups in Morro Bay, California, on top of a kelp forest ecosystem. This is what it looks like below a kelp forest ecosystem with sardines in Monterey, California. Here's another kelp forest resident, a common octopus. This one's in Tasmania off the south coast of Australia. And a giant squid. I'm not sure where this photo was taken. Here's a rare sighting of 24 Baird's beaked whales, including 2 calves off of Monterey, California. California has all the good stuff. This was a pod of more than 1,000 dolphins swimming off Dana Point in California. And of course, no collection of marine life images would be complete without a breaching humpback whale. And this one was taken off of New South Wales in Australia. All right, so this brings us to the present state of the oceans. And I included 2 statements on this slide from recently published scientific articles to highlight the present state of the oceans. Around 1 million species are currently threatened with extinction due to human activities. This comes from studies done by the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, or IPBS, which was published last month. And a scientific study published in Nature in 2019 found that ocean species are going extinct faster than terrestrial species, maybe up to twice as fast. And we're going to talk about the reasons for that coming up. As I mentioned at the beginning of this presentation, the Anthropocene mass extinction event has been happening for about the last 150 years, since the Industrial Revolution. It's an accelerating mass extinction, meaning that it's getting worse faster, with each passing year. And since the first Earth Day 51 years ago on this day in 1970, when awareness of these issues started to gain traction, we haven't done nearly enough to reverse the damage, so it has gotten much worse. And we can see changes happening all around us, and sometimes it seems like we are passive observers waiting to see what happens next. But the reality is we are active participants in these changes and in their mitigation. The state of the oceans today is very similar to states we've seen before in other mass extinction events. Warming ocean temperatures, the polar ice caps and glaciers are melting, resulting in sea level rising. The concentration of dissolved CO2 or carbon dioxide in the oceans has been steadily increasing for 150 years, to the point that it's high enough to cause ocean acidification and enough temperature increase to change ocean circulation patterns. The current rate of extinction is estimated to be 100 to 1,000 times the average or background rate over the last 10 million years. And future extinction rates are estimated to be 10,000 times the average rate. So it really is a mass extinction event. Scientific studies suggest ocean species are going extinct at a rate much higher than terrestrial species, as I mentioned before, and we're going to talk about that. Scientific consensus on the cause of this mass extinction is human activities. The rapid burning of fossil fuels is one of our more serious activities for several reasons. Think about all the time it took Earth to make fossil fuels, which you can think of as stored carbon. It took more than 100 million years to store all that carbon as organic plant and animal material, and then another 100 million years to convert that organic material into a different form of stored carbon, fossil fuels, oil, coal, shale, natural gas, etc. But it has only taken us about 150 years to release more than 200 million years of stored carbon back into our atmosphere and oceans. The removal of natural carbon sinks through increased urbanization and bad land use practices has only exacerbated this issue because even more CO2 ends up in the oceans. On April 3rd this year, just 3 weeks ago, scientists measured the highest CO2 level in our atmosphere in more than 3 million years. And by 2050, 30 years from now, it's estimated that we're going to be at the highest level in more than 20 million years. Now, even though we exhale carbon dioxide every few seconds, we can't actually see or smell excess CO2 gas in the atmosphere or dissolved CO2 in the oceans. It's basically invisible to us. So we tend to think it's not really there, not really doing all this damage. But using scientific equipment, we can easily measure CO2 concentrations and we can see its effects on living organisms. Measurements and observations have provided us the direct evidence to know what is going on. A release of this much carbon this quickly does not allow organisms or entire ecosystems time to adapt to the major changes that are happening. And that's why this mass extinction may end up being so bad and have such a long recovery time. The rapid burning of fossil fuels and the removal of natural carbon sinks contribute to 2 of 5 key environmental issues caused by humans, resulting in the mass extinction of numerous other species that share this planet with us. Ocean acidification is one reason ocean species are going extinct faster than terrestrial species. The ocean is 25% more acidic than it was just 150 years ago at the beginning of the Industrial Revolution, as a direct result of CO2 released from burning fossil fuels since then. We know this from multiple independent lines of evidence looking into the deep past and from direct pH measurements over the last 150 years around the globe. The oceans act as a buffer to excess CO2 in the atmosphere by dissolving it in seawater, where the carbon becomes available to marine organisms that use it to make shells and skeletons. And as I mentioned earlier, when those organisms die, they sink to the bottom of the ocean where that carbon remains stored for thousands to millions of years, thus removing it from the surface of the earth. So the oceans have been this tremendous sink to excess carbon dioxide in our atmosphere. But when there's too much dissolved CO2 in the atmosphere, it ends up in the oceans, and that excess combines with seawater to make carbonic acid and hydrogen ions, both of which increase acidity. And under acidic conditions, these carboniferous shells and skeletons don't form properly. So marine organisms who need them don't survive. Ocean acidification also affects the formation of proteins, fertilization, and other critical cellular and developmental functions in most marine species, including plankton and other microbes at the base of marine food webs. The collapse of marine food webs triggers a domino effect on every single species throughout the world's oceans. So this is why so many marine species are going extinct when the oceans are even slightly more acidic. And when it occurs this fast, 25% in 150 years, marine species are going extinct at a faster rate because they just simply don't have time to adapt and evolve to these changes. Warming oceans is another key environmental issue causing mass extinctions today. CO2 that remains in the atmosphere is a greenhouse gas that traps solar and other heat that otherwise would have radiated out to space. We're also seeing methane gas being released in massive explosions in Siberia, leaving behind methane craters. And if you recall, methane was one of the contributing causes of the largest mass extinction of the Big Five, the Permian mass extinction, because methane is 20 times worse as a greenhouse gas than CO2. CO2 and methane cause global warming and other climatic changes, which in turn causes the oceans to warm. As we've seen in past states of the oceans, warming has occurred several times in Earth's history, and it was always associated with increased volcanic activity releasing CO2. But this time, scientists know that the CO2 causing global and ocean warming is from us, burning fossil fuels, because there hasn't been an unusual spike in volcanic activity in millions of years. And we can estimate with very high confidence the amount of fossil fuels we've burned since the beginning of the Industrial Revolution, and from that, estimate how much CO2 has been released into the atmosphere, and they match pretty well. And scientists can actually look at carbon signatures, isotopic carbon signatures in the atmosphere and oceans, which tells us the precise source of the carbon, just like fingerprints. In fact, carbon signatures are so precise that scientists can readily distinguish carbon originating from volcanoes, forest fires, agricultural and urban sources, fossil fuels, and even different types of fossil fuels like coal, oil, and natural gas. And for decades, oceanographers like myself, we've used carbon released from atomic bomb tests in the 1940s and 50s to measure currents throughout the world's oceans, because we can distinguish between bomb carbon and other carbon in the ocean and watch how bomb carbon flows around using these currents around the world from various points of origin when the bombs went off. So this stuff lasts for a long time, and we can tell the different sources using these carbon signatures. Now, scientific consensus is nearly universal that the CO2 causing global and ocean warming is from us burning fossil fuels and eliminating carbon sinks. There are a few scientists who dispute this consensus, but there aren't very many of them, and they don't have good evidence to support their opposing claims. Scientific studies show that marine species, especially cold-blooded species, have low tolerance to temperature increases because they're already living at or close to their upper temperature limit. And since they are cold-blooded, they have no way to regulate their body temperature. And there's no refuge for them to escape warming oceans. As a result, many marine species face extinction or have already gone extinct as a result of warming oceans. Ocean acidification and ocean warming are why marine species are going extinct at faster rates than terrestrial species. Acidification and warming both occur on land and in the atmosphere, but the negative effects are less severe than in the oceans. And there are ways terrestrial species can avoid acidic water and soil and find refuge from heat. Marine species can't. What's happening in the oceans is happening everywhere on Earth. It's just worse in the oceans. As if ocean acidification and warming aren't enough, marine species also have to deal with pollution, habitat destruction, and overfishing from human activities as well. This article, published in Nature in January this year, highlights how serious a problem like just overfishing is for ocean wildlife. In only 50 years, the authors found that the global abundance of all oceanic sharks and rays has declined by 71% due to an 18-fold increase in relative fishing pressure. Some populations have declined as much as 90% as they're overfished for sport and to make fin soups. 90% of sharks gone just to make soup. It's kind of crazy. Because ocean wildlife is not as visible to us as life on land, we can't see these effects as easily. But scientific studies and reports from non-governmental organizations and even citizen scientists at sea are saying the same thing. Human activities are harming ocean wildlife more than life on land. Human activities create environmental stress in the form of toxic chemicals, micro and macro plastic pollution, harmful algal blooms, pathogens, man-made disasters, habitat destruction, and so much more, all of which affect the overall health of our oceans. As a biological oceanographer, I am very concerned about the health of the oceans affecting the health of everything living in them, which impacts us humans as well. So what does all this mean for potential future states of the oceans, extinctions, and us? The past has shown us that mass extinctions tend to have multiple causes. Species may be able to survive one or two, but when they get hit with so many serious challenges so quickly, they become overwhelmed, and eventually enough individuals in a population perish and the species goes extinct. This is happening now all over the world in the Anthropocene, from human activities causing all these serious challenges for species everywhere. Nowhere are these challenges more daunting than in the oceans. I volunteer with Saving Ocean Wildlife specifically because 2020 was a global wake-up call for me to take more action and to motivate others to get involved. For decades, scientists and citizen activists have been warning of the consequences of human activities for life on Earth, and 2020 was the year Mother Nature made us pay attention. Although a global pandemic and destructive fires in Siberia and Australia and California, and apocalyptic orange skies over San Francisco and Seattle, and methane craters in the Russian tundra, and increasing marine extinctions all seem like unrelated events. They're all coming from human activities resulting in severe climate and ecosystem disruption, with the potential for mass human and wildlife casualties. Scientists are increasingly sounding the alarm about the seriousness of these key environmental issues for life on Earth, including us. These issues have become political, so no mitigation has been accomplished in the 51 years since the first Earth Day in 1970, because we are mired in political stalemate. And during periods of political and social turmoil like the last few years, environmental issues are forgotten or moved to the back burner. And so seriousness has become dire. And I think we will see years as bad as or worse than 2020 more frequently. But don't take my word for it. Here are top global experts in their own words. This article in Frontiers in Conservation Science was published in January this year. I think it is one of the most important articles to come out in a while because it speaks credibly and honestly about how dire the situation actually is. It was co-authored by 17 scientists from top universities and organizations around the world who mince no words regarding how we have grossly underestimated the challenges of avoiding a ghastly future. The authors state that we report three major and confronting environmental issues that have received little attention and require urgent action. First, we review the evidence that future environmental conditions will be far more dangerous than currently believed. The scale of the threats to the biosphere and all its life forms, including humanity, is in fact so great that it is difficult to grasp for even well-informed experts. Second, we ask what political or economic system or leadership is prepared to handle the predicted disasters or even capable of such action. And third, this dire situation places an extraordinary responsibility on scientists to speak out candidly and accurately when engaging with government, business, and the public. They go on to say that the science underlying these issues is strong, but awareness is weak. Without fully appreciating and broadcasting the scale of the problems and the enormity of the solutions required, society will fail to achieve even modest sustainability goals. This article was published in CNN last month to reach a maximum number of people around the world. Its authors include the Director General of the United Nations Educational, Scientific, and Cultural Organization, or UNESCO, the Chairman of the Intergovernmental Panel on Climate Change, the Chairman of the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, the United Nations Envoy for Oceans, and others. These are the top global organizations involved in climate change and biodiversity issues around the world. It does not get more credible than this. They state that intersecting and escalating crises, climate disruption, the collapse of biodiversity, the declining health of the ocean, and the depletion of natural resources clearly demonstrate that we cannot continue on our current path. Our relationship with nature, traditionally based on domination and exploitation, has already altered some 75% of the land surface and 40% of the marine environment. The global rate of species extinction is tens to hundreds of times higher than the average rate over the past 10 million years. And around 1 million animal and plant species are threatened with extinction. This cannot continue. The scientific evidence calls for a complete change, a total overhaul of our relationship with nature and biodiversity. This is not an option, but a necessity for our survival. The welfare of humanity relies on the health of the environment as well as the well-being of other species. The time to act is now. One of the most important messages to take home from this presentation that I'm giving right now is that we don't know what will happen to us humans if there is a cascade effect of species extinctions and subsequent ecosystem collapses. And we don't know how quickly a cascade effect could occur. The question is not if the planet or life will survive this sixth mass extinction. They will. We already know this by looking at past mass extinctions, both in the oceans and on land. The question is, will we survive? And how many other species will go extinct as a result of our destructive activities? Unlike cyanobacteria 3.5 billion years ago, we are conscious of what we are doing and we can choose to reverse course. So what can every individual do to make a difference and help reverse course before it is too late? These are a few of my suggestions. We shouldn't wait for governments or organizations like the United Nations to act first. It is imperative for individuals to make changes in their personal lives now, no matter how small the change, even if it's only substituting a reusable bag at the grocery store or a reusable straw at Starbucks. Doing something is better than doing nothing. And by starting with something, you may find that doing more is even better. Visit the Saving Ocean Wildlife website to download this list of things you can do to make a difference by adopting a plastic-free lifestyle. There's another on how to minimize toxic chemicals at home that end up going down our drains, into sewers, and eventually the sea. We recently posted a video about entanglement in marine debris that blows there from land. And we can connect you with experts who are trained to rescue entangled animals at sea. I'm sorry to say it, but overconsumption in affluent countries like the United States is one of the biggest causes of the 5 key environmental issues, because we have the wealth and cultural attitude to use and waste more resources than most other countries. And this is not meant to make anyone feel guilty or to lay blame. It's all of us. We need to minimize our use of everything from fossil fuels to water, plastics, toxic chemicals, and even seafood. Even hip new technologies like artificial intelligence, smartphones, and electric vehicles come with disastrous environmental costs and consequences. It seems that every generation falls into the same trap that technology will save us in the planet we all share from ourselves. So whether it's horses to cars or petroleum to electric or Terra to exascale computing, there are often environmental costs that don't become apparent for decades. So we all need to be conscious of the choices we are making now. How many times do we need to repeat the same mistakes of short-term thinking when we already know the long-term consequences of strip mining and environmental degradation on land, and now in the ocean bottom to obtain lithium and other rare elements for rechargeable batteries in electric vehicles and consumer electronics? We need to put our collective money and energies into truly long-term sustainable solutions and not be forced to change direction again in 25 or 50 years when things have gotten worse rather than better. Community projects have an even bigger impact because people working together can do more than individuals alone, such as community trash cleanups at local beaches, parks, streets, and neighborhoods to prevent trash and plastics from ending up in the oceans through wind and sewer runoff. Planting trees in community gardens help convert areas into carbon sinks to remove CO2 from the atmosphere and counteract the negative effects of urbanization. And by spreading awareness of these issues in your community, more and more people may get involved. If you want to become more involved, there are legislative actions going on around the country, such as bans on single-use plastics, toxic chemicals used commercially, industrially, in our homes, and more. There are also legislative actions to enact more marine protected areas in the US and international waters, such as 30 by 30 legislation to protect 30% of the world's oceans and ocean life by 2030. We're currently at about 6%. So individuals who back this legislation are needed to move it to completion. Because of human nature, or beware of human nature pitfalls that we've witnessed again recently, including a mistrust of science, denial of facts, spread of misinformation, pseudoscience, And even something that most of us do, which is optimism biases, that everything's just fine, it's all going to work out, so we don't really need to do anything. Or fatalism, that these outcomes are inevitable, so we don't really need to do anything either. We can't understand these issues through pure reason or gut instinct or armchair science. People who have dedicated their lives and careers to understanding these issues through empirical scientific methods have been saying for decades that we need to take this seriously. And we're saying it even louder now. The situation is dire. So this is also a call to be more vocal, especially scientists, conservationists, and others who know, understand, and can effectively communicate scientific information about these issues, but also educators, community leaders, and concerned citizens. Scientists in particular are trained to be cautious about overstating anything. So we tend to understate everything, which in my opinion has resulted in decades of underestimation of the seriousness of these issues. Opponents don't exercise the same caution. And so the battle to change public perception has been lopsided and riddled with misinformation. We must change this by being more vocal and stop understating everything. It seems somewhat silly to suggest environmental activism in these sophisticated, often cynical times, but it really is incumbent on us all to tell it like it truly is. As individuals, there is much we can do in our personal lives to make a difference, but collectively, we can move mountains of trash and legislative logjams if this becomes a movement. I want to leave on a really positive note. One of the best things to come out of COVID-19 restrictions last year was that 2020 had the biggest reduction in greenhouse gas emissions in human history, showing us that we can do it if we try. Now that COVID restrictions are lifting, we can choose to go back to the way things were, or go forward by making different personal choices that minimize our collective impacts. This is not an Earth Day message of despair, but a call to action. The situation is not hopeless, and we should not surrender to it, but strive with all our will and resolve to protect our only life support system, planet Earth. With that, I would like to thank everyone for joining us tonight. I hope this has given all of you a very thought-provoking Earth Day. Please send your questions via the chat tool, and I will answer as many of them as I can. And I've got a bunch of supporting slides, so I'm actually going to stay in the slide presentation, and Laura's going to ask some of the questions in the chat. And if I have the slides for those, I can show them so that it'll make more sense.
Great. Well, thank you so much, Michael. Ton of information. Thank you for making this such a comprehensive presentation and really helping us to reflect on the past, which is what informs our future, right? So if we don't know where we came from and what we experienced, it's going to be really hard for us to manage our futures. And we're talking about ocean wildlife here, but as you said, we're all connected, right? So this definitely impacts us. So thank you so much for that. A lot of information. Really looking forward to folks' questions. So please, as Michael said, just type them in the chat. I have one question here that says, how is artificial intelligence bad for the environment?
Yeah, you know, I've actually got a slide for that one. Let me search for that. Hang on just a second. Can everybody see that slide?
Yep, I can see it. Wow, that's cool.
All right, so a 2019 study that was done at the University of Massachusetts Amherst and discussed in this issue of MIT Technology Review showed that training a single artificial intelligence model, in this study a natural language processing model like Google Translate, for those of you that know Google Translate, that's a natural language processor. It emits as much carbon as 5 cars over their entire lifetimes, including the carbon used to make the cars. They compared several carbon footprint benchmarks in pounds of CO2 equivalent, shown in the table on the left. The average US car uses 126,000 pounds of carbon over its entire lifetime, from manufacture to burning fossil fuels to disposal. But that typical AI model that they studied used more than 626,000 pounds of carbon over its life cycle, 5 times more than the average car. And large data centers owned by Amazon, Google, and Facebook have such large energy needs. Most of them have their own power stations powered mostly by gas and coal, as shown in the table on the right. You can see renewable gas, coal, nuclear, and they have Amazon, AWS, Google, and Microsoft. And Google's the only one that's actually using a higher percentage of renewable energy over fossil fuels or nuclear. But Amazon, which I think is the largest one, they're still using gas and coal, which is one of their biggest suppliers of the energy, just to run these data centers for everything that we do, from Gmail to everything. So there's a huge carbon footprint. It's kind of weird. And even things like cryptocurrencies like Bitcoin have a huge carbon footprint in their blockchain algorithms. A study done at Cambridge University this year found that Bitcoin compute algorithms use more energy than Argentina. And if Bitcoin were a country, it would rank in the top 30 energy consumers worldwide. So it's kind of surprising and eye-opening to think of massive compute technologies emitting this much carbon when we tend to think of them as clean technologies. Who asked that question, Laura?
So I'm having difficulty with receiving the questions on chat. I think people are sending them to Ralph, and he's sending them over to me. So I couldn't see who that was.
Oh, okay.
But Ralph, maybe you know?
Oh, that's okay. All right. Well, thanks to whoever asked that question.
That would be C. Wassoff.
Great. Well, thank you, folks. Please keep sending them in the chat. If you don't mind sending them to me, Laura, that'd be great. And the next question is, Michael, could you tell us a little bit more about mining in the ocean, and particularly related to maybe our needs for lithium batteries that we're using? How is that impacting the extraction from the ocean?
Yeah, I've got some interesting slides on that. Hang on just a minute. Yeah, it's definitely an environmental issue causing alarm among deep sea marine biologists and oceanographers like me. Electric vehicles and consumer electronics need certain elements for rechargeable batteries and other components. And two of the most important elements for rechargeable batteries are lithium and cobalt, both of which are mined extensively on land in countries not necessarily friendly to US interests, which sets us up for future problems like we currently have with oil and have been trying to get away from by going electric. So it's kind of weird that we're setting ourselves up for this failure already. These slides show lithium mining in evaporation ponds. I think this one is in Bolivia. This one is in Chile. And BMW is actually commissioned a study on trying to sustainably mine lithium, but it's virtually impossible. And then this is a strip mine for cobalt in the Congo. And all of these places have these associated political, labor and environmental problems that we think we're avoiding with newer, purportedly greener technologies. But the reality is many of the same problems are there, even with these new technologies, and we need to be aware of that. And in an effort to avoid some of these problems, mining companies are securing federal contracts in the United States and elsewhere to mine the ocean bottom for lithium, cobalt, and other rare elements. And this slide shows some of the equipment and methods used in seabed mining, and talks about how California, Oregon, and Washington states are trying to block federal mining contracts off their coast because of how destructive it is. So as a biological oceanographer in general, and as a deep sea expert in particular, I'm very concerned about physical habitat destruction on the ocean bottom, where benthic or bottom dwelling organisms have developed complex ecosystems over billions of years. And in addition, the process of mining rare elements and anything else produces these toxic waste materials that are stirred up and spewed out into the ocean water column from the bottom to the surface, where toxins may harm and even kill numerous organisms that come in contact with them. And ocean currents disperse that toxic waste material all around the oceans, harming organisms over very large areas far from the mining site. So this is why several coastal states are trying to block federal mining contracts off their coasts. And this is another type of legislative action I was talking about earlier that individuals in these states can get involved in.
Great, thank you, Michael. We have a few more questions here and even less time because we want to be respectful of everybody's time. The next one is, there's a big push towards greening the ocean with supporting seaweed culture as a carbon sink source. But isn't it funded by fossil fuel interests exploring a shift to biofuel? So how do we approach this potential conflict of interest?
Unfortunately, I don't have slides for that one, but I'm happy to take that on. I mean, I'm personally against those kind of mitigation efforts because I think in order to seed blooms, algal blooms, which are the microscopic photosynthesizers that suck up CO2 and produce oxygen, you usually have to put some kind of nutrient into the water. And there have been scientific experiments where they've done that with iron. Iron tends to be a limiting nutrient that gets added to the water, and you can get these massive blooms. And so there's been talk about trying to do something like that to stimulate these massive phytoplankton blooms for that purpose, to suck down more CO2 and put out more oxygen. But the problem is that anytime you do that kind of a mitigation effort, you can end up with organisms that aren't natural out competing the natural ones that were there, because the natural ones have evolved to the conditions in that area. And once those conditions change, you can really alter the natural ecosystem to something that's quite different. And we don't know what the long-term effects of those kind of changes are. So I personally tend to be against them, because without fully knowing and understanding what the repercussions are over long periods of time, it's very hard to say that it's going to have a positive impact in the end.
Great, thank you, Michael. And I'll just take one last question just due to time, and I'll actually answer this one. This is from Deborah, who's asking, gosh, we know the situation is dire. That's definitely evident from this presentation. What would be some things that we can actually do? We're talking about big potential solutions that could involve having to get governments to shift what they're doing, getting the fishing industry to change what they're doing. But what can all of you do as individuals, I think is what the question is asking. And I want to leave you with three things that relatively simple. One is, and Michael touched on this, the plastics issue. I noticed with COVID that a lot of people got out of the habit of bringing their own reusable bag to the grocery store, because a lot of stores wouldn't let you do that. It is okay to bring your bag back, even if you just do that to reduce that. Again, fossil fuels generating single-use plastics makes absolutely no sense. 20 billion plastic bags a year are used in California. We could be the difference. We could cut that down. Secondly, we talked about extinctions, mass extinctions in this presentation. But what's happening here off our coast of California is we have animals that are endangered, that could be on the brink of extinction if they get entangled, if they get hit by ships. And so what we really need is folks to report what you see, even if an animal isn't able to be rescued. The information that it brings to the folks that are trying to figure out what's happening to these animals is crucial. So again, if you do nothing else, when you're out on the water, just remember what that phone number is to report if you see an animal in distress. And if both of those things sound too difficult, one thing that you can do is super easy. You can go to our website and make a donation. Because certainly what we're doing is we are spreading this message through webinars like this, raising people's awareness about what's going on with the ocean. We're also doing direct outreach through our Dock Walker program. And we are doing our best to get everyone to know about how to report so we can help save these animals. So please consider a donation. You can go to our website at www.savingoceanwildlife.org. I want to thank you, Michael, for your presentation this evening and all the effort to get all those wonderful slides together. Amazing. You had slides right on hand to answer those questions. That was so valuable. Thank you so much. And to the whole Saving Ocean Wildlife team for making this possible, and to all of you for caring about ocean wildlife. We'll see you soon. Take care.
Thank you.